Welcome to MyProjectBazaar.com. This is our project title, Unsupervised Feature Selection with Control Redundancy. This is our project abstract. Features selected by a unsupervised technique often include redundant or correlated features. While use of correlated features may result in an increase in the design and decision-making cost, removing redundancy completely can make the system vulnerable to measurement errors. Most feature selection schemes do not account for redundancy at all, while a few supervised methods try to discard correlated features. We proposed a novel unsupervised feature selection scheme which not only discards irrelevant features but also selects features with control redundancy. Here, the number of selected features can also be directed. Our algorithm optimizes an objective function which tries to select a specified number of features with a control level of redundancy such that the topology of the original data set can be maintained in the reduced dimension. Here we have used Simon's error as a measuring of preservation of topology. We demonstrate the effectiveness of the algorithm in terms of choosing relevant features, controlling redundancy, and selecting a given number of features using several datasets. We must a comparative study with the 5 unsupervised feature selection method. Our results reveals that the proposed method can select useful features with control redundancy. Then this is our data flow diagram. Then start the program and load the unsupervised dataset which is related to our system. Then find correlated coefficient matrix using standard deviation method. This correlated coefficient matrix is helpful to control redundancy of the data. Then find Euclidean distance Xij. Xij is nothing but the original dimension of the data set. Then initialize beta value. The beta value is helpful to find out the Euclidean distance Yij. Yij is nothing but a reduced dimension of the data set, and then both Xij and Yij is used to find out the Simon's error. The Simon's error and some functions like pf1, pf2, pf3 is used to find out the error functions and using constants like b, c, d. Then compute beta new value using beta old value. Then recompute the matrix for all DNN values with beta new values. We must compare beta new value difference between beta old value is greater than the epsilon, then the condition is satisfied. Then move to next condition. Exponent beta value is greater than the lambda, then the great feature is selected as a selected features. Then stop the functions. And now we run our project. This is our home screen. Click enter button to enter our system. Select database, it's Iris database. After clicking this Iris database, we can see the Iris data set. Then click next button. We separated the unsupervised dataset from the Iris dataset. Then click show button to show the Iris dataset with unsupervised data. Then click process correlated data to find out the correlated coefficient matrix. Click the and show the show button. Click on show. After clicking show button, we can see the correlated coefficient matrix dataset. Then find origin distance. The origin distance x, that means the original dimension of the data set. Then click show button to show the data of the origin distance xij. Then give beta value as 3.005. Then find origin distance y. After clicking origin distance y, origin distance yij, that means a reduced dimension set of the iris. Then click show button. We can now the data are appearance in the screen. Then find Simon's error. After clicking the Simon's error, we can click show button to show the Simon's error values. Now the values are appearance in the screen. Then give enter R value. We can give R value as 2. Then click next button. Then compute BCD. That means the BCD as a constant to find out the error function E. Then click enter beta B value as 15 and C value as we can give 1, D value as 15. Then click compute BCD. Now the Simon's error values and PF1 function, PF2 function and PF3 function are values are appearance in the screen. Then click show button to show result. The results are appearance in the screen. That means the error function values are appearance in the screen. Then click next button. We can now selecting the features. Find new error function E using the old error values. Show the both of the values. Then start selection button. After start selection button is clicked, then selection features are screen are appearance in the screen, appearance in the window. Then click show button. Now the graph are appearance in the screen and the selected features are appearance in the screen. Then the average of the features. This is a graph. Then click on button to end the function.